Good morning, everyone, to our first live Q&A session of the day. I am joined by Stefan Schneid, the scientific lead of parentals and drug product development at Bayer AG, Davide Pastore of chemical engineering at Politecnico di Torino, and Jeff Smith, the professor of process analytical technology at De Montfort University. Firstly, welcome to you all. And if anyone has any questions for our speakers, please do type these into the chat and during this session. So first off, Stefan, we will start with you. Using empty vials to reduce the edge effects for those close to the edges of the would it be possible to improve the shielding by using water-filled vials?
Yeah, so thanks, Jeff, for the question. I read it during the presentation. So generally, you can, of course, also fill the surrounding vials with water. We do not typically choose to do that because this way they will change during the process. So they will, of course, also freeze and sublime. And this way lead to an active kind of bulk cooling effect to the adjacent vials through the removal of heat by sublimation at even lower product temperatures. And that is kind of defeats the purpose. So it would overcompensate the reduction of radiation effects and provide active cooling instead of radiation. So that's why we instead rather just load empty vials around it so that there will be a more or less constant shielding effect throughout the process, but not somewhat active cooling.
Yeah, that makes sense. Yeah, thank you.
Great. And then Davide, over to you. If you change vial type, do you meet the RP determination and the KV determination in micro freeze drying?
Well, actually, part of the study has to be repeated in the sense that vial type affects the way heat is transferred to the product in your vial. So when you change the container, you need to repeat the thermal characterization, but actually you need to repeat it just in micro FD. So it's a very fast test, not so expensive in terms of time. With respect to the behavior of your product, actually, it is not expected to change when you change the container. So your RP, the cake resistance, is not expected to change when you modify the type of vial. Obviously, in case you will be able to avoid collapse of the cake. Okay, so you change vial type, you change the way you transfer heat, so you probably need to modify the operating conditions of your process, but keeping in mind that you want always to avoid the collapse of the cake, then RP should not change, and so you do not need to repeat the test for determining RP. You may do a validation test, but actually it is not needed to do this test.
Great, thank you for that. And then over to you. Do you expect any differences between the critical temperature recorded by DSC or free microscopy and that observed by TVIS?
The critical temperature, well, yes and no, because when you look at DSC data, you're working on a very small sample. So the way the sample freezes, way any crystallizing component comes out, if it doesn't, could be different on the larger scale of the product inside the vial. So and we have seen instances when we heat up, like you would do in a DSC experiment, evidence of devitrification occurring in the vial. we don't see it in the DSC. So I guess if we were using TVIS instead of the DSC, then it potentially would give you more reliable in-vial predictions as to what's going on. But not always the case, you know. There's obviously a lot of people just rely on glass transitions and collapse temperatures in freeze-dry microscopes to understand what the collapse temperature is going to be. And that TG is dependent on the amount of water that's associated with the solids fraction. So that's going to be a primary concern, whether that changes if you're going from a small to larger scale. But I mean, ultimately, I suppose the acid test is whether the actual product collapses in the vial, which, you know, could potentially be different to how it collapses in a freeze-dry microscope, or, you know, as I said earlier, how TG could vary between a DSC and what you measure in the vial. So I don't know. I mean, maybe confirmatory tests with TVIS might be useful in that regard.
Great, thank you very much, Jeff. And then back to have you any idea about the energy consumption of these new alternatives compared to conventional freeze drying?
That was a bit interrupted. I understood. I have an idea about the energy consumption of the new alternative technologies. And that is not so straightforward to answer, because the batch size obviously differs a lot. So for a conventional large-scale freeze dryer, of course, you have a lot of stainless steel around the product, which needs to be heated and cooled all the time, and that obviously consumes a lot of energy, as well as especially the condenser, shelf cooling and heating, and also of course the autoclaving, the zip process is also a factor in that. So for maybe starting with the ReaVita continuous lyophilization, the footprint of the system is typically smaller, and especially the inner volume is a lot smaller, because there you have these kind of tunnels where you transfer, at least in the GMP unit, the vials after spin freezing through load locks and provide heat input through NIR radiation and or infrared radiation. And this will, in addition, lead to a much shorter process time. So instead of maybe 50 to 100 hours or so on average, you can reduce the process time to 1 or 2 hours. So that's really a drastic difference. But of course, you have a lot less vials that are being processed at the same time. So that would need to be related back. So I do not have exact numbers here for the energy consumption, but at least for the ReaVita process, I'm sure that this will be considerably lower if you calculate it per vial than a conventional freeze drying process. For the N-Wave process, which is currently being further developed also to a GMP type by GEA, there you have a relatively similar setup as in the conventional freeze dryer, also with a somewhat smaller footprint, and you have a much faster throughput. So here you have less heating and cooling of stainless steel involved, but of course you need to generate the microwaves and then consume them again in water, the surplus that you don't really need by the product. And I would suppose that the energy saving is not as substantial as for the ReaVita technology, but still it will be less than for conventional freeze dryer. And for Meridion, the situation is a bit different, because there you have a huge apparatus which you cool with liquid nitrogen in order to first solidify the droplets, and then afterwards have a kind of bulk freeze drying process as well. And this, I don't have numbers here either, but I don't think it will be a huge saving per dose regarding the energy consumption.
Okay, great. Yeah, Davide.
I have a question for Stefan concerning the energy consumption or the energy transfer that is obtained in this alternative method for freeze drying. What I mean is this: in the traditional freeze dryer, so in which you have your liquid solution over the shelf, the way in which you transfer your heat to the product is not the most efficient method you may have, but it can be quite easily controlled by the operators. Okay, so you may, you may set up your operating condition in order to avoid overheating and so on. What's your feeling about this in, for example, when you have microwave or when you use microwave for heating, when you use radiation, like in the Ghent system, or when you have granules? That is a system in which, heat transfer and the control of heat transfer may be not easy at all. Do you have any feeling, any idea about this problem? Well, I don't know actually if it can be a problem. Okay, it's just one of the main difference with respect to the traditional system.
Yeah, of course. Maybe again starting with the ReaVita Ghent system that you started with. Here, on the one hand, the product is spin frozen, so the solution is on a much thinner layer thickness as a film on the side of the vial, and this of course facilitates the drying, and also reduces the impact of the product resistance, because if the layer thickness is less, then also the temperature change over the drying is reduced. And one of the advantages in the system is that you have individual heaters, infrared heaters, combined with a thermal camera. So you have a thermal imaging of the vial wall, so that you know at least what the temperature of the product adjacent to the vial wall is over time. And this enables either processing or heating each vial individually, to a certain target set point below the critical temperature, of course, or you could also use kind of the same setting for all with a slightly higher safety margin. So there, I think it's better controlled and more uniform actually per vial than in standard bulk freeze drying processes. For the microwave, of course, there you have still a number of vials that are heated at the same time, and where you transfer the microwave energy into a certain array, either a rack or these circle fractions, and that of course will lead to a higher inhomogeneity compared to the ReaVita process. They compensate that partly by moving the vials. So this is kind of like a turntable which rotates above the microwave source, kind of like a standard microwave, in order to create some distribution. But of course, there is some potential for heterogeneity caused by that. And finally, from Meridian, this is kind of like a coater, where you have this bulk of pellets, and this is rotated during the drying process all the time. So this is constantly mixed, and the overall energy input which is also done by infrared, is very homogeneously distributed. So there may be like local differences, but since it's all the time rotated, it should be averaged out quite easily.
Okay, I see. Thanks.
So, thanks for the question.
Great, thank you so much for providing a few details on that, Stefan. And then Davide, over to you. After process development in these dryers, what kind of tests are needed at an industrial scale?
Well, actually, you need just to carry out the validation test. So what is quite often called the engineering run for validation purposes, because using the approach I talked about before, you don't need to do any preliminary study in large scale unit and then to replicate that dynamics, that features in micro FD. Using the approach I showed you before, you perform your study in micro FD, you properly use the data that you will obtain, and you will get immediately the information for carrying out the test in another unit that may be even an industrial scale one. And then you need to perform the validation as for all the other cases. Obviously, in this way, you just focus on the so-called central vials. That may be 80–90% of the vials of your batch that are heated by the shelf. You do not focus on the edge vials that receive a different amount of heat depending on radiation and so on. Those vials actually, the dynamics of the product in those vials is dependent on the specific equipment that is used. So if you want to focus on central vials, the majority of the vials, on vials where the drying rate is lower, and so that are responsible for the process duration and so on, actually you don't need to carry out an experiment in larger scale unit, just a validation test. If you want a more detailed picture, taking also into account edge bias and so on, okay, you need to do the thermal characterization of your larger scale unit with the gravimetric test.
Great, thank you very much for that. Out of time, but one quick last question for Stefan, sort of touching on that before. And how much time do you think these alternative technologies will sort of be true for aseptic applications, and what work is still needed to get there?
Yeah, so I'm not part of any of these technology companies, of course, and can only comment from the outside there on what is communicated officially there. So both Reavita and Enwave, I said, have communicated that they are preparing GMP lines and GMP prototype equipment, which they will then further refine. So far, I'm not aware that they are used for GMP purposes, but this can be expected, I suppose, within the next 1 or 2 years. And Meridion, they already have a large technical unit, which is kind of a GMP layout. But I'm not aware of progress towards GMP application in this technology.
Okay, great. On that anyway, and any last questions for each other at all?
Maybe I tried to give a quick question, or ask a quick question to David. I'm interested in the the heat flux transducer in the micro FD. So how pivotal is that sensor to all of the modelling that you do? How important is it?
I'm sorry, but I didn't heard you very well. Could you please repeat
Okay.
the question?
Yeah. I'm asking about the heat flux transducer in the micro
okay.
FD. How important is it? How pivotal is that to everything that you've done?
Well, actually, you have in micro FD, you have the heat flux sensors at the bottom that measures the heat flux to the vials. Actually, I used it in the past, and to tell you the truth, I did not consider it very reliable. I don't know why, actually. It probably is related to the way this flux is effectively measured, but it's a level of detail that I don't know. I do not have a specific knowledge about it. But in any case, even the producer of micro FD, they claim, well, you carry out the test, you determine a sublimation length. So you know the time needed for obtaining sublimation of a certain amount of ice. Okay, you divide the amount of ice by this time and you find the sublimation rate. Okay, you multiply sublimation rate by heat of sublimation, okay, and you get the heat flux. Then you compare this number to the heat flux measured by the sensor in the machine, and you find a correction factor. Actually, this correction factor may change depending on the test, on the operating condition, and so on. So actually, I don't know what this sensor actually measures, but it measures something that is a little bit different from what we consider the heat flux to the product. So in the end, what I suggest is to carry out your standard gravimetric test, obtaining the KV, the usual KV, and by this way you have a parameter that may be used for process transfer. Then, as a side result, you may get also this correction factor if you want to use the sensor in the machine. Okay, it's a side result that you may have. But in my view, is not the most reliable way of using this tool. Okay, so to save time, because you want to save time, you need to do the gravimetric test. Then obviously you have a Liosim that provides additional heat to the product, and it is for this that I proposed the 2 layers model, and with the 2 layers model I'm able to distinguish between heat that is reached, that arrives to the product from the shelf, and the heat that is exchanged laterally. This because for the calculation, I do not use just the amount of water that disappeared, the amount of ice that disappeared, but I use the additional information that is the temperature profile, the temperature dynamics, the way the temperature reaches the asymptote value. So I use two pieces of information, weight loss and the temperature profile, and using the best fit approach, I may get the two heat transfer coefficient, one from the bottom and one from the lateral side. By this way, I don't care about the heat flux sensors and so on. I immediately get KV used for scale up purposes.
Yeah, okay. I thought it would be not a quick answer, but it was a very informed answer. So thank you.
Well,
Great. Thank you very much. We have just had one last question come through on the chat. Running a bit out of time. We've got a presentation starting in about 3-4 minutes time. But that is on the Stockwell app. If any of you are sort of able to answer it, back to whoever posted it in the chat there. So we don't have time to address it now. But I do just want to thank you all for joining for the Q&A session, and thank you for all your presentations this morning. And we look forward to seeing everyone a bit later. Thank you very much.
My pleasure.